Hello, welcome to another video. In this video, we will be discussing elasticity from an economics perspective. Elasticity is a unitless measurement used to make comparison between variables that are of different units. For example, comparison between changes in quantity demanded for a good as the price of the good changes. As we know, we measure price in the currency. So, for example, the United States dollars, and we measure the good depending on which type of good it is. For example, if we are measuring wheat or rice, we measure them in kilograms or grams. So how can we compare the change in the price, which is in dollars, and the change in the amount of wheat that the consumer buys, which is in kilograms or grams? These are two different units, dollar and kilogram. So how can we make a comparison in the change in the price in terms of dollar and change in the quantity in terms of kilogram? So that is where elasticity comes into play. Another example of how we use elasticity is comparison of how two different goods respond to their changes in prices or change in any other factor that affects the good. For example, we may want to see how does the change in the price of Pepsi affects the change in the quantity of Pepsi, and at the same time we may want to see how the change in the price of Coca-Cola affects the quantity demanded for Coca-Cola. So we may want to look at each individually, and at the same time we may want to compare them to each other. Which one is more responsive to the change in price, which one is less responsive to the change in price? That is what elasticity is meant to do. In economics, elasticities are usually interpreted with percentages. At the introductory level, we usually calculate elasticity of demand and elasticity of supply. So in this video, we will focus on the formulas we use in calculating elasticity of demand and elasticity of supply. In actuality, there is only one formula for elasticity. So elasticity of demand has just only one formula. Elasticity of supply has just only one formula. It may seem as if there are a lot of formulas to calculate the different elasticity that we have under demand and supply, but actually all the formulas originate from a single formula, and we shall do that breakdown, and we will explain when to use the different formulas and in which situation. We are going to start with elasticity of demand. Do note that everything we learn about elasticity of demand can equally be applied to elasticity of supply. So elasticity of demand equals percentage change in quantity demanded divided by percentage change in the factor that affects the quantity demanded. This formula may seem too long. However, this should help you remember what elasticity of demand stands for and how it is calculated. In an abbreviated form, this formula can be written as elasticity of demand equals percentage change in quantity demand divided by percentage change in the factor. So elasticity of demand is percentage change in quantity demand divided by percentage change in the factor. This simple formula of elasticity of demand covers all the formulas used to calculate the different type of elasticities of demand. First and foremost, it is important for us to note that depending on the question, there are two main ways we may approach the calculation of elasticity of demand. Elasticity of demand can either be calculated as point elasticity or as arc elasticity. First, let's start with analyzing point elasticity of demand. Point elasticity of demand. Point elasticity of demand. In a simple way, the best way to know if the question is asking you to calculate a point elasticity is in the question, you will see the words at, you may also see the word when, and any other similar vocabulary to those words. When you see these keywords in the question, then definitely the question is asking you to calculate point elasticity of demand. What do I mean by that? The question may say, calculate elasticity of demand when price equals $5. So the keyword here is when. This means we are asked to calculate the point elasticity of this demand when the price is $5. Now let's go about it. Different type of way the question may be given to us. The first way a question may be given is question given with percentage values. If the question are given in percentage values, the elasticity formula, the point elasticity of demand formula we're going to use is E. We are representing elasticity of demand as E. The elasticity of demand E equals percentage change in quantity demanded divided by percentage change in the factor. For example, if the factor in the question is price, we simply replace the word factor with price. That means elasticity of demand equals percentage change in quantity demand divided by percentage change in price. Or if the factor in the question is income, we simply replace the word factor with income. So elasticity equals percentage change in quantity demand divided by percentage change in income. As simple as that. So when the question is given to us in percentage values, we use this formula. The second scenario is if the question is given to us in numbers or table or graph or schedule. The formula we're going to use is derived from the basic formula. Like I mentioned earlier, we have only one formula for elasticity of demand. So let's break down this formula to get which formula will we use when we have numbers, tables, schedule, or graphs. We know that elasticity equals percentage change in quantity demand divided by percentage change in factor. Now, this formula contains only percentages. It does not have numbers. So we need to decompose this formula, or we need to break down this formula in a way that can be used when we have numbers or tables given to us. To break it down, percentage change in quantity demand is actually gotten by the general way of calculating growth in anything is the current value, let's call it Q2, minus the old value, let's call it Q1, divided by the old value, which is Q1, multiplied by 100. In a more simplified form, the difference between the new value and the old value is the change in the variable divided by the old value multiplied by 100. This is a breakdown of this first part of the elasticity formula. Similarly, let's break down the second part. Percentage change in factor equals the new factor value minus the old factor value divided by the old factor value multiplied by 100. That is equal to change in the factor divided by the old factor value multiplied by 100. This is a breakdown of this formula. What we did here is simply using a growth formula of anything. So when a particular thing is in a particular situation, we compare it to the old situation divided by the old situation multiplied by 100. That is the change in anything. For example, if the price of a good was $2 and now the price of the good is $5, so the growth or the percentage change in that price is the new price, which is 5, minus the old price divided by the old price multiplied by 100. So if the factor is price, we replace F2 with price 2 minus price 1 divided by price 1. The new price minus the old price divided by the old price. That's what we just do. But you don't need to apply that here. We will give a general formula that can be used at any time. This is just to show you how we are going to get that general formula at the end. Now let's go back to our decomposition. Let's apply this. So E equals percentage change in quantity demand will be replaced with change in quantity demand. In short form, to make it easier, let's remove the D and just leave only Q, divided by the old quantity multiply by 100 divided by change in the factor value divided by the old factor value multiplied by 100. E equals 100 will cancel out 100. So we are left with change in quantity divided by Q1 divided by change in factor over the old factor. This is equal to change in quantity over, let's get rid of the 1 and just call it simply quantity. Now, because the sign here is division, to change it to multiplication, we have to invert the value after the division sign. So it becomes, from change in F divided by F, it becomes F over change in F. So we can leave it like this. We can apply this to write it in a more aesthetic way. E, elasticity of demand, equals change in quantity divided by, we switch the places of these two values because switching the place does not matter. 2 times 3 is 6. 3 times 2 is also 6. So either you multiply 2 with 3 or you multiply 3 with 2. It doesn't change the value. So Q times change in F is the same thing as saying change in F multiplied by Q. So we replace this Q with change in F, then multiply by the factor divided by quantity. Now, this formula looks more aesthetic. Like I've mentioned previously, the factor is simply anything that can affect the quantity demand. So if I'm calculating price elasticity of demand, and I have just only numbers, so I replace it with change in quantity divided by change in, instead of writing the factor now, we will replace the factor with price because the price is the factor in this question. The price is the factor. So multiply by price divided by quantity. And if you are calculating income elasticity of demand, income elasticity of demand, it is simply equals change in quantity divided by change in income multiplied by income over quantity. Like I said previously, this formula is used for numbers or tables, for tables and graphs. A quick example, just to help your understanding. Let's say we are given price and we have quantity demand 2, 10. So when the price of the good is 2, the quantity demand of that good is, let's say, 8. And when the price of the good increases to 10, the quantity demand for that good reduces to 4. So the question says, calculate the price elasticity of demand when the price is 10. Solution. As we've explained previously, we can see that the question is a point elasticity because the keyword is when. So, and the values we have here are given to us in table format, not in percentages. So we use this formula. So elasticity, the price elasticity, the E P representing price elasticity of demand equals change in quantity demand divided by change in price, because the factor in this situation is the price. The factor here is the price. The factor here is the price. So we replace F with P. Multiply by the factor, which is price, divided by the quantity demand. Change in quantity demand, as we've shown earlier. So where change in quantity demand simply means the new Q minus the old Q, as simple as that. So change in QD is, we may choose any one of the two values. We may choose this as the old Q, we may choose this as the old Q and choose this as the new Q. It doesn't matter. But what is important is we have to keep the consistency in the old and the new values. So if we choose this QD as old Q, if we choose this 8 as old Q, we must also choose this price as old price. And if we choose this 4 as new quantity, we must also choose this 10 as new price. The consistency has to be kept. So this is new. Change in quantity demand equals the old Q, which is 8, minus the new Q, which is 4. That's equal 4. Similarly, where change in price equals the old price minus the new price, change in price equals the old price is 2 minus the new price, which is 10. The consistency has to be kept. It is very important. 2 minus 10 is negative 8 minus 8. So we bring in those values, we substitute them into our formula. So price elasticity of demand equals change in quantity demand is 4 divided by change in price is negative 8 multiplied by the price and the quantity demand. How do we know which value of P to use? How do we know which value of QD to use? This depends on the question. We are calculating point elasticity. So we are calculating the elasticity at this particular point. So when price is 10, so that means P will be 10 divided by quantity demand. So when the price is 10, the question gave us when the price is 10. We go back to the table and look. When the price is 10, we can see that the corresponding quantity demand is 4. So 10 divided by 4. The consistency has to be kept. It is very important. Doing the calculation, price elasticity of demand is 4 divided by 8 is negative. 4 divided by minus 8 is negative 1 over 2 multiplied by 10 over 4. EP, price elasticity of demand equals negative 1 multiplied by 10, that's negative 10, divided by 2 times 4 is 8. Negative 10 divided by 8 equals negative 1.25. So how do we interpret this answer? This means if price increases by 1% quantity demanded will decrease by 1.25%. So the decrease already represents this negative sign, hence why we didn't say the price would decrease by negative 1.25%. Recall that we said that elasticity equals percentage change in the quantity demanded divided by percentage change in the factor, in this situation, which is price. So, and we've calculated that the answer is negative 1.25. If we simply apply the basic mathematics rule of all values always having divided by 1, and we introduce percentage, we can see that this interpretation holds. If this value here increases by 1%, this value will decrease because of this negative sign, decrease by 1.25%. So if price increase by 1%, quantity demand will decrease by 1.25%. This concludes the second situation of point elasticity of demand. The third situation is if the question is given in equation form or as a function. For example, if the question gives quantity demand equals 40 minus 5p. This question is given in a function form. It is different from percentage. It is different from having a table or a graph. So how do we approach this question in this situation? At the beginning, we said elasticity of demand equals percentage change in quantity demand divided by percentage change in factor. And we said this is used when we have the question directly in percentages. And this can also be rewritten as change in quantity demand divided by change in the factor multiplied by the factor divided by the quantity demand. We've shown how this was gotten. So in this situation, we can use neither of these formulas. So we need to establish the third formula, which is gotten from the second. So this was the first. This was the second. We need to establish the third formula. So we say from elasticity of demand, which is equal change in quantity demand divided by change in factor multiplied by factor divided by quantity demand. In calculus, we know that differentiation of a function, for example, let's say differentiation of the quantity demand function with respect to price is written as differentiation of quantity demand with respect to price, which is read as the QDDP. In this situation, the price is the factor. So to generalize it, let's replace price with factor. This is exactly equal to change in quantity demand divided by change in the factor. These are equal to each other. So from here, we can establish that price elasticity of demand when we have a function equals the QD dF taking the derivative of the quantity demand function with respect to the factor multiplied by the factor divided by the quantity demand. This is the third formula used when question is given in equation form. A quick example, using the demand function we had above, given QD equals 40 minus 5P. Calculate the price elasticity of demand when price equals $5. The word when specifies that we are calculating point elasticity of demand. So we know that price elasticity of demand, because the question is given to us in function form, is the QD, the F, the factor. In this situation, the factor is price, multiplied by the factor, which is price, divided by the quantity demand, where the QD, the price, so we differentiate the quantity demand function with respect to price. That should give us minus 5, where the price equals 5. The question gave us the price as 5, and where quantity demand. In the question, we have no value for quantity demand, but to get the quantity demand when the price is 5, we go back to this equation. We know that quantity demand is 40 minus 5P. Since we are calculating the price elasticity of demand when price is $5, so it simply means the quantity demand equals 40 minus 5 into 5, because the price is 5. So that's equal, quantity demand equals 40. 5 times 5 is 25, and the answer is 15. So we input all of the values we've gotten. Price elasticity of demand equals the QDDP is one value. This is one value, not two separate values. The QDDP is minus 5 multiplied by the price is 5 divided by quantity demand is 15. So EP equals minus 5 times 5 over 15. 5 here, 1. 5 and 15 is 3. So the EP, the price elasticity of demand, is minus 5 divided by 3. And that's equal negative 1.667. This simply means if price increases by 1%, quantity demand will decrease by 1.67%. And this completes the first part, which is point elasticity of demand. This approach that we've learned can also be applied to point elasticity of supply. We simply replace the QD, the values of the QD in each formula. You simply replace them with QS and you get exactly the same thing. So point elasticity of demand will just become point elasticity of supply. So anywhere you see QD, simply replace it with QS and the rule and everything still stands. In terms of when you have percentages, in terms of when you have numbers, tables, schedule, or graphs, and in terms of when you have the question given to you as a function or an equation. The second part, which is arc elasticity of demand, actually builds on what we've learned on point elasticity of demand. Arc elasticity of demand. This is used when the question is given keywords. The keywords in the questions are usually from, between, or any other word similar to these keywords. So we've established before that when we have percentages, the formula does not change in this situation. Arc elasticity are usually asked in just two main forms, which is when the question is given in numbers, table, or graph, and when the question is given in equation. So how do we approach this? The situation of number one is, we've seen previously that elasticity of demand equals change in Q divided by change in the factor multiplied by the factor divided by the Q. Because we are calculating arc elasticity, these values here are actually points. These are at a particular point. You may refer back to the examples that we solved and to confirm that these are actually at a particular point. However, the question now is in arc form, that is from one point to the other or between 2 points. We simply replace the points with an arc or an average. So in arc form, the elasticity equals change in quantity divided by change in the factor multiplied by the old factor plus the new factor, the old factor value plus the new factor value divided by 2, all divided by the old quantity demanded value plus the new quantity demanded value, or the new quantity demanded value plus the old quantity demanded value, all divided by 2. Let's write it in a more bold way. E equals change in Q divided by change in F times the new F value plus the old F value divided by 2, everything divided by the new Q value plus the old Q value, everything divided by 2. So we end up with E equals change in quantity divided by change in the factor times factor average divided by quantity average. And as we've mentioned before, in the situation 2, when you have an equation, we simply replace change in quantity divided by change in factor. We replace it with the Q, the factor, and the rest of the formula remains the same. In this situation, the elasticity, the arc elasticity of demand, is, instead of writing change in Q over change in F, we replace it with this. So we have the Q, the F, the derivative of the quantity demand function with respect to that particular factor multiplied by the factor averages, the factor average divided by the quantity average. And that's it. This is how we approach it when we are calculating elasticity of demand. The key lies in taking the average values. Hope you found this video helpful. You may check the playlist and we will update the playlist as we solve more questions related to elasticity. Note that everything we've learned about elasticity of demand can also be applied to elasticity of supply. We did not go into details about the different types of elasticity. We did not go in details into the price elasticity of demand, the income elasticity of demand, the cost price elasticity of demand. That will be dealt with in future videos, and if we have done any video regarding that, we will update the description below. Thank you for watching. See you in the next video.